What's up, folks? Welcome back to the channel. In this video, we're going to talk about MCP. Now, what is MCP? Well, check out the official Model Context Protocol documentation. You're going to learn that MCP is an open protocol to standardize how applications provide context to LLMs, right? Think of it like a USB-C port for AI applications. Now, what does that mean? Well, consider this, right? When you have a user interacting with an LLM and the LLM is working and has control over a set of tools like searching the web, checking Wikipedia, checking archives, sending emails, calendar management, etc., right? When I have this little situation, to build the most basic vanilla agent possible, you can set up a little loop that looks like this, right? The LLM has two choices. It can either, given some prompt from the user, right, which will contain some sort of task that the user is sending to the LLM can make a choice. It can either perform some action to go further into resolving the task, or the LLM can return a final output to the user, right? If the LLM chooses to perform an action, the LLM is going to make what is called the thing that's in this line over here is something called a tool call. Okay? What does it mean, a tool call? It means calling a tool, preparing inputs for some specific function that performs an action, like calling an API, executing a program, and so on, right? The output of that action is going to be, in this context, something called an observation, all right? And what this observation is going to do is going to provide more information to the LLM in order to finish the task or not. Imagine if the task was to check your calendar, to get the events from your calendar, the LLM might call the calendar tool, and that might lead to an output that is the recent events and their descriptions, right? That's going to be the observation that's produced out of the output of the tool, and that gets fed back to the context of the LLM. And now the LLM can make a choice. The LLM can say, okay, given that, what I'm going to do is I'm going to write a little summary for the user, and now I'm ready to give the final output. I don't need to use any other tools. And this is something that works, folks. This is something great. This is something that's powering most of the AI agents that you use today, okay? Now, the trick here is that in order to set this up in whatever framework you want, whatever language you want, you have to write the code for the LLM API access. You have to write a code that connects these LLMs to different tools and resources. And you have to write the code for the logic of the agent, how this workflow is going to go. Now, the example that I demonstrated here is a basic agent loop, something called, like I was showing before, a React loop. And if you don't know what React is, that's a reference to this paper called React, Synergizing Reasoning in Enacting Language Models. And in this paper, they showed that you could have a lot better performance with large language models if you have them interleave thoughts, actions, and observations out of the actions they take and go systematically solving more complex tasks. Now, React is awesome, and this loop works, but you do have to write all of this code. LLM API access, connection to tools and resources, the logic of the agent, and so on. All right, so what's the problem? Well, the problem, as I've come to realize after reading a very cool, I think it's a course or article by Hugging Face on MCP, is that you get to this situation where you have multiple possible LLMs accessible. If you want to use different LLMs within this system, for each of them that you're going to have to write the connections to the tools, resources, and prompts. So you end up having to write a lot of redundant code, right? Because that leads to like M multiplied by N integrations that you have to maintain in your code, as demonstrated in this beautiful drawing that I have over here, okay? So actually, a really good source on this topic, if you want to go deep into not only this, but just an MCP intro in general, is this course by Hugging Face, MCP, which pretty much goes into all of the stuff that I'm talking about. And this is where I went to get this idea of the multiple connections, right here. Once you have a bunch of models and multiple tools, number of integrations becomes too large to manage, each with its own unique interface. All right. So it leads to this problem of too many integrations to maintain, right? And MCP, folks, as I'm demonstrating beautifully over here, is trying to solve that problem, okay? So MCP is trying to turn a problem that previously was M multiplied by N into a problem that is now M plus N, number of integrations to maintain. So if you want to switch LLMs in your system, if you're using MCP, as long as they connect to MCP, MCP is going to connect them to resources, tools, and prompts. So you don't have to write that many integrations anymore, right? So M integrations for how many models you need to connect, and N integrations depending on, you know, how many resources you have, tools you have, prompts, and so on and so forth, okay? So this idea is pretty cool. It works, beautiful. So this is the scenario where something like the model context protocol shows up, right? And what does it mean to say that MCP tries to facilitate connecting LLMs to context? Well, for that, let's take a look at the documentation, right? So here they talk about why MCP, and they make a similar argument to what I just made. They go into the architecture. We're going to talk about that in a second. And then they show you how to build these different agents. Now, if I go over actually to my own little diagram over here, I think it's the best way to quickly go over this topic. I'm going to actually pull up my presentation. Let me just pull that up. There we go. And here we go. Here we are. So what's up with MCP? So here's the thing, folks. Now, I'm going to actually jump over to the side that I want to present. There you go. So what MCP is doing is essentially this, all right? MCP is saying, okay, check this out. You have three major core components for the MCP infrastructure, okay? What are these three components? Well, we start with the host or user-facing application. This is your application. This is where the thing is going to live, okay? So you have a host that can be, for example, a great example of an application that today can integrate easily with MCP servers is something like Claude Desktop or different IDEs like Cursor and others, all right? So you start with your host user-facing application. Inside of that host, we're going to have clients. Now, what is a client? It's something that's going to handle one-to-one connections with MCP servers, all right? And what is an MCP server? An MCP server is something that's going to expose functionality. What functionality? Tools, resources, prompts, right? Just like we were talking about before. It's going to expose anything that might be useful to use by an LLM, okay? And like I was demonstrating in this beautiful drawing here, yesterday when I was teaching this course to actually 780 people, the LLM lives inside of the host, which means that the host is responsible for implementing the LLM providers, okay? Now, this is great, but how can we actually get a sense of, like, get an actual idea of what this looks like? So instead of me continuing to go on the very details and specifics of what the host is, what the client and the server are, let's just write some code and see what that looks like, okay? So I'm going to pull up my editor here. There we go. I'm going to open up a file, and I'm going to save this file, and this is going to be my simple server. I'm going to call it my simple MCP server.py, okay? And for this simple MCP server.py, I'm going to try to do it by head, but if I don't remember, I do have some cheats here because I already wrote this code before. But so if I don't remember, I'm going to go and cheat a little bit and check that out. So we're going to import from MCP the FastMCP module, all right? That's going to allow us to create, I think it's a Fast API MCP server, Fast API based MCP server. I'm pretty sure, but let's check that out. I'm not actually 100% sure. So mcp.server.fastmcp docs fastmcp MCP protocol. There you go. Python SDK. And then Python SDK, I actually want to know, yeah, this is a simple server that exposes. I'm going to go ahead and think that FastMCP is just a fast API based MCP server. All right, I'm fine with that. I mean, obviously set up your environment, right? So here in this folder, I have an environment that I don't want to use actually. So I'm going to deactivate this environment. Going to deactivate. In the Model Context Protocol documentation, if we go over here, the way they advise you to set it up for server development is to use UV. So that's what we're going to be using. All right. So if we go over here in the page, there we go, Mac OS Linux, UV init weather, CD weather, venv, source, we add the MCP CLI and HTTPX, and then we create the file. So let's go ahead and let's do all of those steps, all right? So I'm gonna go UV init simple MCP server, beautiful. I'm gonna go into this folder. I'm gonna say UV venv. I think that's what I got to do, right? UV venv, and then I'm going to activate that environment. Bin activate. Beautiful. And now that I've activated that environment, I'm going to create the file, right? Yeah, I'm going to add the dependencies. So I have to add MCP CLI. And I have to add HTTPX. And now I have to move the simple MCP server.py file to here. And now we are ready to go. Simple MCP server, we're ready to go. And it's going to be pretty simple. I'm going to say MCP equal fast MCP. I'm going to name my instance simple MCP server. All right. And now we can use very simple decorators to create the functionality that we want to expose. All right. And to give you a sense of what that would look like, I'm going to create two essential ideas, okay? So we're going to start with a tool. So mcp.tool. And now for this tool, I'm going to create a function that creates a file, okay? Given a file path and its content. And what the output of this function is actually going to be is a dictionary that returns this string a dictionary with the file path and the content saved inside that file path, okay? And that's going to be important for later. So now Cursor is already helping me build this thing, so this is pretty cool. I'm going to come over here and see if everything's good. Okay, so with open file path, right? And then write the contents and then return. This message I don't like. What I want to build actually is file path and then the actual content of the file. There you go. I'm going to return this in the dictionary, right? Nice. And now that we have that, I don't want the read file tool for this, okay? I want this tool to create a file, and let's just start with that, okay? So I have this tool that I can now expose to as a functionality as an MCP server. So let's do that. I'm going to say if name.run, mcp.run. Now, there's a default parameter here that I'm going to explicitly state because it's important. It's called transport. And I'm going to say stdio. What this means is that there are two transport layers essentially for MCP, local and remote, okay? The local is called stdio, standard input and output. And this means that this server is going to be exposed in a way that it can be accessed via a simple command on your local folder. And if you don't understand what that means, stick with me. We'll see what that means in a second, all right? So we're exposing the server and everything's beautiful. And now let's see what happens when I just run this script, okay? Simple MCP server. I'm running with Python. And, well, all right. Not a lot is happening. Okay. So what is going on? Right now, the server is open, right? So here's the thing. I wouldn't use it like this because this is stdio, but the idea here is we have this file that we can run, and when we run this file is exposing this MCP tool. Okay? So keep that idea in mind. Beautiful. So now I'm going to stop running this file. Okay, and now I'm going to actually run something that comes installed with the MCP CLI in order to take a look at this server, to inspect it, to debug it, to troubleshoot it. So I'm going to run MCP dev, and then I'm going to give the path to this server, simple MCP server. And now something has started, and now I can open up this little link here on my local host. Let me go over here. Nice. And now we are inside of the MCP inspector, which is a very nice tool to inspect everything about your MCP server. So here it's indicating how you could theoretically run that server. So saying UV argument server.py. So let's see what happens when I click on connect. When I click on connect, now my server is connected. And I can list all the stuff that that server is exposing. So resources, potential templates or prompts, right? I can list the tools. Now, if we go back into that server, we see that the only thing that we are exposing is a tool. So I'm going to come over here in tools, and I'm going to click on list tools. And when I do that, what happens is we get this information that this is the tool that's being exposed by the server called create file. So if I click on create file, we see what are the characteristics of this create file tool. And it creates a file with a given content. So imagine this. I can give a file path, I can give some content, and I could click on run tool, and I could test if this tool is running correctly or not, which is pretty cool. Let's try that out. So I'm going to try locally, and I'm going to say file.txt, and the contents is this file was made with an MCP server. And now I'm going to click on run tool. And now the tool result says success. And the output was this very nice dictionary with the file path and the contents of the file that I put right over here. So this is the inspector is going to be this great tool for us to understand if the stuff that we're exposing with our MCP server is actually working and everything is going well and beautiful and marvelous. So I can go back to my folder, to my editor. I can check that, as you can see over here in file.txt, a file was created, the file was made with an MCP server, so it actually works, which is awesome. All right, this is pretty cool. Now, if I'm going to stop the MCP inspector for now, and even though the inspector is great, this is half the story, right, folks? We've created our MCP server, but like we were talking about a second ago, when we actually have MCP working, when everything is like amazing, we have two aspects of this story, right? We have one aspect, which is the server, and the second aspect is the client. So we made a server, right? How would it work to build and interact with the server via a client? Now, lucky for us, the MCP documentation is really awesome. What they do for us is, in the documentation, if we go down over here, they have an example of a much more complex server than the one that I just demonstrated here, which is great. You should go check it out. It's an async, super nice server. Now, what we're going to do is we're going to go down here where they say client developers. And in this example here on the documentation, they show you how to build a simple LLM-powered chatbot client that connects to MCP servers, which is exactly what we want to understand how all of that little infrastructure works with MCP. So I am very lazy right now. So instead of me writing everything again, what I'm going to do is I'm going to click on the complete code for this tutorial, blah, blah, blah. And I'm going to go over to client.py, and I'm going to copy all this code. And we're going to work through this code and see what's going on, okay? So we're going to copy this raw file. And now I'm going to go over to my editor. And I'm going to open up a new file. I'm going to paste this in. I'm going to call this client test simple MC. Ah, this is a terrible name. Client test.py. I think client test.py is more than enough. Now I'm going to run. Yep. Everything works. One note, folks. I think I've ran my server like Python, tralala. This is probably wasn't. Oh no, that's fine. Yeah, because we created with UV. Yeah, it's fine. So now that we've done this and now we're happy and everything's good, here's what we're gonna do. We are going to take a look at this client code and understand what is it implementing that kind of helps us understand how the whole idea of MCP works. And this MCP client is a very simple class that has a session, something called an exit stack, and Anthropic, which is the easier part to understand here, which is this is going to be responsible for loading up the Anthropic client so that we can use the Claude model as our LLM of choice. Okay, this is actually not our choice. This is the choice from the documentation. Now, if we zoom out a little bit, there are two functions in this client that I want to take note. One to connect to the server, and one to process the query. Okay? Now, there's a third one that's also important, which is the chat loop. Okay? And I don't even care about cleanup right now or main. What I care about right now is something that connects to the server, something that processes a query. Now, check this out. I'm going to put this code on the left, and on my right, I'm going to put the browser. I'm going to open up that beautiful diagram. And I'm going to zoom out of this diagram a little bit. And I'm going to go to another drawing that I really like in order to understand what is going on. And this very drawing over here is actually extremely useful. Now, in this drawing, what we're doing, oh, no, that was bad. In this drawing, what we're doing is we are outlining how the communication flow on a basic MCP client host infra would go down, okay? Now, a really good explanation on all of this is actually right here. Let me just show that to you. If you go to understanding MCP capabilities, it's the Hugging Face course. This is a very great source on this topic, MCP capabilities. I want to find something that was called a communication protocol. There you go, the communication protocol, right? I'll leave a link to this course and to the documentation in the description. Don't worry. So in this communication protocol, they outline everything about how the format works, JSON, RPC, stuff that we haven't covered yet. I'm probably not even going to touch on this video. This is a very introductory video. What I care about, folks, is something much simpler, which is if we go down, down, there you go, discovery, where is the, I thought it was here, maybe I was a bit wrong. Maybe it wasn't communication protocol, maybe it was like the flow, server sends, client reviews, samples, reviews, returns, yeah, and how capabilities work together. I thought it was in the communication protocol, but the communication protocol was more focused on the JSON RPC formatting and how the images are connected. Okay, so that was my bad. So let's just go through this diagram and let's just focus here. This is a basic flow for how the communication is going to go down between user, host, MCP client, and the MCP server. All right? And what is going on? What's going on is very simple. We have the user interaction, right? Sending a query, and then the host processes that query. So you can start to see the connection with the code that we have on the left, right? We have some code over here that's called connect to the server. We have some code over here that's called process the query. And this happens at the host client level. So the host and the client are connected, right? The client then does what? It connects to the server to discover capabilities from the server. So if we go here on my left, we see that there's some code over here to list out the tools from the session. What is the session, folks? If I go a little Control F on the session over here, you see that the session is the client session that was created. Okay, great. And when we take a look and see what this session is actually doing, the session was created to connect to the server via stdio, right? And it has a command to connect to that server, and it has the path to the script for that server. So when we list the tools, we're listing the tools that are being exposed by the server. So we are doing this capability discovery to know what the MCP is actually exposing. And you guessed it, the MCP server is going to go back and say, look, these are the available tools, resources, and prompts. All right, great. So what the client is going to do is say, okay, so now I know this information. So now the LLM that sits at the host application can, if needed, the LLM can invoke a capability. It can call a tool that's being exposed by the server, all right? And then, if that happens and the LLM invokes that, the client sends that message to the server to execute whatever the LLM says the LLM wants to invoke and call and so on. So the server, as I'm drawing more red over here, executes that functionality, returns the results to the client, which relays that back to the host so that the host can integrate that into some chat conversation with the user. And then the user sees some response, and some summary in a chat, whatever it is. And in this code here on our left, we see that at the fake host level in the form of this little chat loop that we have here. That in the case of this script is written in the client, but I do like seeing this code as an example of implementing, an aspect of the host and the client. So I think that this is a pretty simple, easy way to understand how communication is flowing, how the messages are being exchanged. And now we can focus a little bit more here on the code that we have. And if we go up over here, we can now go do a little walkthrough of what the code is actually doing for us. So we're initializing these things, and then we connect to the server, right? To connect to the server, all we need is the path to the script. So we need the path to this simple server script that I wrote. And then this code is identifying if the script is going to be Python or JSON. So I don't even need to check for JSON because I'm just going to build servers with Python. And the server specifies, okay, what is the command to run that? In this case, is Python is fine. It could be UV run script, but Python is fine. And then we have to specify the parameters in this stdio server parameters object, giving the command and then the arguments for that command. All right. And if we have environment variables, authentication stuff, and so on, that would go probably right over here. Then once we've done all of that, we have some boilerplate to set up the transport, the stdio, the write, and the entering the async context. I'm not even going to pretend that I know what's under the hood here, folks. What I care about is that we are initializing our session. All right. Okay, we're initializing our session. This is beautiful. The next thing is to process the query. So this is something that we are more used to when we're playing around with LLM APIs, right? Preparing a message for some OpenAI model, some ChatGPT model, some Claude model, whatever it is. So this is usually going to be a list with dictionaries containing a role message that says user or assistant or system message and the content of the query, right? So this is the query that the user is going to be sending for the LLM. And then we're going to wait for the response to get, we're going to make that call and say, what is the functionality being exposed? We get the information of what is the functionality being exposed. And we put that into a little list and we send a message. We send a message to, in this case, to Claude, right? self.anthropic.messages.create. We send a message to Claude. Maximum number of tokens is 1,000. Messages and the tools available. The tools available are going to be organized in this very nice little list of dictionaries containing the name of the tool, the description of the tool, and the input schema for the tool so that the model knows how to properly send input for that particular tool. And remember, when we say tool here, in the case of our example, it's just going to be this tool, which is a tool to create a file. All right? Beautiful thing. So now we can process and handle those tool calls. This is great. And then here is a classic loop to process a message that might contain a tool call or might contain a message for the user. Now, folks, I want you to take a look at this little easy loop here, because this is a classic. Loop for an agent. What do I mean by that? When we were over here, we were talking about this loop, right? We were talking about this loop. User sends a message, the LLM can use a tool or respond. So if I put this side by side with this, we can actually see how everything comes together. So we analyze the content of the response. If it is text, we append that to a message that's going to be sent to the user. So that would be the final output. Or context for the LLM, and so on. Then if in the content output of the LLM, there's an indication of tool use, well, then we're going to understand what is the tool that should be used, what are the arguments for that tool, and then we're going to call that tool. So we are taking care of the execution of the tool here, because we're not using any frameworks that usually do that for us, like LangChain, LangGraph, or Google ADK, or OpenAI Agents SDK, or the OpenAI Old Assistance API, so on and so forth. And then we append the information that we call the tool to a little list containing information saying calling tool, blah, blah, blah. Okay? So this is interesting, because now we are in the context of the model that we're using. This information about what happened if we call the tool is being added, so the model knows what happens in the past, so the model can do something. Remember, these LLMs have no memory whatsoever. We have to do the work ourselves. And now we have a second message to kind of concatenate everything together, and we append everything to the final message for the user, right? We append the final text. And here's the thing. You've seen code like this before MCP. If we go to something very obvious, if I go over here to the OpenAI function calling docs, you've seen code that looks something like this, right? So we've seen, if I go down, 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 let me see if I find an example that looks very much like this. Yeah, I think this example here, right? OpenAI, you initialize a client, you have a list with tool schemas, messages, and then you get a completion, and there's a possibility of calling tools because the tools are being given to the model. And then you see the output, and the output indicates, no, I want you to call a function. And what is the name? What is the argument? Okay, and then you execute a function. So you get the tool call, you get the arguments, and then you execute the function. You see get weather and the arguments for the function. And look at this. Now this is being implemented in the client, because self.session represents an instance of the client session. And this is using this call tool that's going to call this tool. I just have to give the name and the arguments. And the reason why we can do this is because we are exposing tools with the MCP server so that they can be called and executed and so on. And this will essentially send all of this information for execution on the server. All right, so perfect. Now that we've kind of done, we can actually test this out. So here's what we're going to do. We're going to run this client. And in order to run, we're going to have to specify what is the path to the server script. That's all. That's all we got to do. And notice I don't have to run this server because we're using transport stdio. So I can just come over here. I'm gonna run, I can run with UV run, and then I can give the client test, and the path to the server is simple MCP server. And that didn't work because I didn't install Anthropic. So I did install Anthropic in the, that's true. So UV, I think I can go UV add Anthropic, then UV run, client test, and then the path to the server. Nice. So now we connect it to a server. We know that the tools available are create file, and I can say, write a 3-paragraph essay on pancakes and somehow relate it to the idea of standardization protocols for building production-ready LLM agents. So we're going to send this input, and we're going to analyze, we're going to take a look at what happens as we are sending this input. Processing request of type list to request. You see that a to call was made. And then we're saying that I'll help create this essay by writing it and saving it to a file. We see that it's saved to a file called pancakes in standardization.txt. Pretty nice. And we can actually inspect and see if that file actually exists. So I'm going to run Control P and then pancake something. And then here we are, folks. We have a wonderful essay about pancakes in standardization. Just as the perfect pancake requires a standardized recipe and precise execution, development of agents demands well-defined protocols and blah, 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 blah. This is awesome. So in a very simple and easy manner, where all of the complexity really just came from the code that we took from the MCP protocol for the client, we were able to build a simple server. We exposed a very simple functionality, and we accessed that functionality from the client side, and we used it, which is pretty awesome. So thanks for watching, folks. Don't forget to like and subscribe, and see you next time. Cheers.